Welcome to Past Engineering, guys. Okay, and I hope you guys, all of you, have read and watched my part one video, and this is my second part two video in the Laplace transformation. Let's do it. Okay, part two Laplace transformation. So easy topic, and here we're gonna find the Laplace transformation. We're gonna find the Laplace transformation of the sin 80, the sin 80, and the Laplace transformation of the cos 80. Cos 80 Laplace transformation and their inverse and their inverse and their inverse and inverse and inverse also, and this one is very important thing. Okay, let's do it here. Okay, here, and the Laplace of sin 80 equals to integration of the 0 to infinity e power minus st dot sin 80, same is. And let's do a simple integration by using a bypass, we know that, and the integration of this and the integration of this, and the leaving integration of the first function and the sin 80, and this one is another, and the integration of the sin 80 that leaving the sin 80 is as well as constant, and put the limit minus time the integration 0 to infinity derivation of the sin 80 this function leaving function, and dot the integration of the second function sin 80 uv rule dt. And by putting the limit here we get the 0 by 0, we got the 0 into 0 and 0 into 0, and a by s equals to integration 0 to infinity e to power minus st dot cos 80. This is the Laplace. This is this formula is the same as the function of the Laplace transformation, and we get the a by s equals to Laplace of the cos 80, Laplace of the cos 80 a by s, and here is also the Laplace of, here is also the Laplace of, and Laplace, here is the Laplace of sin 80, yeah, sin 80, and the relation between the Laplace of the sin 80 and the cos 80 is this. But we need to find the individual Laplace transformation of the sin 80 and the cos 80. For this, let's proceed of looking forward. Okay, and here we get, and we need to find the Laplace of and we need to find the, and we need to find the Laplace of the cos 80, Laplace of the cos 80, Laplace of cos 80 equals the same as the 0 to infinity e to power minus st dot cos 80, and same using the bypass rule, using the bypass and the integration of the first function and uv rule, integration of the first function, integration of the first function, yeah, and this one is integration of the first function and leaving the second is as it is, and the again the derivation of the first function, yeah, yes, and using the bypass you can get this, and using the limit 1 by s minus a by s, and the 1 by s is the limit for this, and this one is the minus as it is, and here you get the one is the important thing, a by s is common, right away a by s, and 0 to infinity e to power minus s is sin 80. This is the Laplace transformation of the sin 80, yeah, we know that Laplace transformation of sin 80, and so right, 1 by s equals to 1 by s, 1 by s minus a, 1 by s minus a by s Laplace transformation of sin 80, and here is a cos 80, here is a cos 80. Laplace transformation of the sin 80 can be written as, and Laplace transformation of the sin 80 can be written as the a by s times the Laplace transformation of the cos 80. We know the relation, and here, and we get the one of the important formula, and the Laplace of the cos 80, Laplace of the cos 80 equals to 1 by s minus a by s sin 80, and the Laplace of the sin 80 converged can be converted to a by s Laplace of cos 80, and here is a constant term, and this term can be yes, a square by s square Laplace of cos 80, and here is also a cos 80, here is also a, we have a cos 80 Laplace of cos 80, cos 80 Laplace of cos 80, here is also, so rearrange them in a like term in one side, and so we get the Laplace of cos 81 plus a square by s square equals to 1 by s, and Laplace of sin 80, and you get, and if you do some simple calculation, and you get, if you get, and you for this for yeah, and Laplace of cos 80, and this is divisible by 1 by s, 1 by s, so 1 by s into s square plus a square, and you get the s is constant equals to s equals to s divisible by s square plus a square, s square plus a square. This is the Laplace of cos 80. Laplace of cos 80, and we're gonna find the Laplace of cos 80, and again we need to find the Laplace of, and we need to find the Laplace of sin 80. Yeah, Laplace of cos 80, we find the Laplace of sin 80. Okay, and for this let's make a 1. Okay, and we know the Laplace of cos function cos 80 equals to, you know, that s upon a s square plus a square, and we know that, but we need to find the Laplace of sin 80, sin 80, yeah, and we know the Laplace of sin 80 equals to a by s times the Laplace of cos 80. Yeah, we know this relation, cos 80, Laplace of cos 80. So, and we know the value of the Laplace cos 80, and the a by s into Laplace of cos 80 into s divisible by s square plus a square, s square plus a square, and we got the final relation is a square. We got the final relation, s is cancel out, so a by s square plus a square, s square plus a square. This one is the final relation. So let's write over here. It's a function, and let's do a simple calculation. Let's do some simple calculation. Okay, and here Laplace of sin 80 equals to Laplace of sin 80, sin function 80, Laplace of sin function 80 equals to a be any constant term divided by s square plus the a square, and its inverse of a Laplace of 1 by s square, 1 by s square plus a square, 1 by s square plus a square, which equals to sin 80 divisible by a. This is the Laplace of the sin 80 and the cos 80. The Laplace transformation of the sin 80 and the Laplace inverse of a sine function. Yeah. Okay. Let's write up again the cos function. Yeah. Cos function. Laplace of a cos 80. Laplace of cos 80 equals to yes divisible by cos. For cos, here is a yes, yeah, mnemonics for you guys, and plus divided by s square plus a square, and the Laplace inverse of the yes means cos yes, s square plus a square, and s square plus a square, s square plus a square equals to cos 80. Yeah. Okay, let's say, okay, let's elaborate with some simple example. Okay, we're going to do the simple example. Okay, for this also, and we have the hyperbolic function. Okay, I'll write the only the answer of the hyperbolic function. Laplace of sin 80, sin s 80, sin s 80, same is the trigonometric function a by s square, and here is a square, but for hyperbolic here is a minus, and same is cos hyperbolic 80 Laplace equals to same, cos means yes divided by same is negative minus a square. This one is the function, and for the inverse also same, but here is only a minus function, so ignore this, and let's make some example. Let's make some example over here, and find the Laplace of a find the Laplace transformation. Find the Laplace transformation of the function sin sin 2t, sin 2t simple. Sin 2t equals to, we know the formula, sin means the a divided by s square plus a square means the 4, simple. And for the same function, and find the Laplace of the cos 5t, same is yes, no change, and s square plus a square, a means 5 square, that is equals to 25. And if you get the hyperbolic, yes, if you get the hyperbolic over here, yes, sin h hyperbolic, and if you get the cos h 5s, nothing is changed, but only a, that means the cos h 5, nothing changed, but only a here positive sign is replaced by negative sign, and here positive sign is replaced by negative sign for the hyperbolic, yes, hyperbolic cos h, and for the hyperbolic sin h. Okay, hope you everyone understand this, yeah. So easy. And let me write the inverse of this function. So interesting and so easy, the inverse. Okay, it will be better if you do inverse and Laplace transformation simultaneously, and it will be more easier to understand and to remember also. Otherwise you will be in the problem. And the next class we'll discuss about the first shifting theorem, okay, and the second shifting theorem for the Laplace transformation and the Laplace inverse. Yeah, first shifting theorem, okay, and we're going to do the simple calculation over there. And for the same problem, okay, and find the Laplace inverse. Find the Laplace. What is the Laplace inverse of the s divided by s square plus 49? Yeah, simple, by 49. This is the formula. Same as the cos. Here is a plus, so cos trigonometric function 7 means the, what is the 7 means 70. Yeah, simple. And for this, if here is the negative, if you get the here negative value instead of the positive value, and then function equals to cos hyperbolic 70. Yeah, simple, cos hyperbolic 70. And for this, oh no, and this sine, let's make a one more example. This inverse of 1 by s square plus 81 equals to, and 1 by s square plus 81 and 1, that means there is no s, so sine 90 divisible by, that means the a, there is no a, so it goes to here a. And if you replace that, this plus t plus sign with a negative sign, and you get the sine hyperbolic 90 divided by, that means this is not a, this is the 9, this is 9, and this is also 9, a. Okay, I hope everyone understand this. In next class, in next lecture, we're going to discuss about the first shifting theorem, and what is the use of first shifting theorem, second shifting theorem for the Laplace and the Laplace transformation. Okay, hope you and meet you in the next class. And for this, stay tuned. Watch the other video tutorial too, and okay, and subscribe to Fast Engineering. Okay, okay, love you all.